All right, thank you for joining us right here on this video we recorded for you at the CVC, Computer Vision Conference 2019 in Las Vegas. If you're looking at this video, maybe you've attended or maybe you missed out. We're hoping to provide you some information on what went on here, and we're interviewing some of our guest attendees and sponsors and partners. We're going to talk to Julien Griffaton from Safran Aircraft Engines, joining us here from France, right?
Yes.
Great to have you here.
Thank you very much.
What brought you to this conference? Why did you came?
Well, I work in edge monitoring, and I think that we need the cooperation and the collaboration of mathematicians, and especially in pattern recognition, because we are looking for patterns in vibration signals, and I think that the mathematician could help a lot to this objective.
So you say here, you come here then also because it's a great place to make those connections?
Exactly, to know more about mathematics, and anything that could help in my job.
Yeah. Well, awesome. Great to have you with us. And we're going to talk a little bit about your specialty. Right now, your role is to develop new algorithms for health monitoring and key performance indicators. To submit several problematics for health monitoring with vibrations.
Exactly.
Yes, it sounds exciting and also very important, especially when we're talking aircrafts.
Yes.
Health is a very big issue, I can imagine.
Yes, I can give you an example. For instance, the example of one of my obsession is to prevent bearing failures, because in an aircraft engine, you have most of the time you have two shafts that are supported by bearings, and when the bearing fails, well, first the engine is shut down, so it's not a matter of safety because an aircraft can fly with only a single engine, and the pilot can land safely. The problem is that the secondary damage are so huge that you lose. The engine can be repaired, so it's a loss of the engine, so it's a loss of several millions of dollars. So this is very important.
There's a lot to gain on preventing that.
Yes.
Can we prevent that by measuring and algorithms?
Yes, we already do that. We are not perfect, so we miss several times, and it's a lot of money there, but we succeed sometimes.
So when it comes to measuring and so what are key elements to what you guys are implementing that we were not doing before?
Well, first we have good accelerometers, so we got good measurements, and this for several years. And now what we need is to discriminate clearly the patterns that we want to identify, not to miss damaged bearing.
I can imagine that this takes a lot of data to learn the algorithms, how to recognize a possible failure.
Yes, and the difficulty is that we don't have a big data set, so we have to learn normality. We can't learn specific abnormal behavior, so this is one of our challenge.
And is this all being done like in a resource facility or a research facility, or is this also something that you can do like in the field?
We do it in the field too. Yes, we have also embedded algorithms, and so we do it. We do this in the field.
So when we're thinking about the costs that this could save, you could really save and safety as well.
Not safety.
No?
It's not a matter of safety at all.
Okay.
Just a matter of business.
Ah.
And what we can save is, depending on the year, it may be several to dozens of $1 million per year.
Well, I guess this makes it why the industry is so eager also to develop these systems.
Yes,
yeah,
exactly.
So what would be the next big thing? Like, where could we expect this to also turn up in the aircraft?
I think it would be a prognostic, to be able to learn the delay before an impending failure will happen. So this is the next step.
We're almost like we're turning into predictors.
Exactly. Yes.
To make accurate prediction of potential failure.
Exactly. Now we are at the stage of diagnosis, and we are looking for prognosis.
Awesome. Well, I certainly hope that you get some new connections that you make here to bring them in. Because is there any field of knowledge that you would say it would be very enriching to add this knowledge to your work?
Oh, I think a machine learning engineer will help a lot.
Yeah. Well, we have a lot of those presentations going on. Was there a presentation you've seen so far that really stood out for you, that you had some inspiration of?
Yes, I saw a presentation that was dealing with a neural network that would not use that many big data sets. So it was very surprising for me. Ah. And I think there is something to learn there.
Well, merci bien pour votre time. This is the limit to my French. I want to thank you so much for just sharing your thoughts and your ideas with us. And if you're hungry for more, and I hope you are, please check out our other videos. You can subscribe to our channel, obviously. We'll be making a lot more available for you. Or consider joining us for one of our conferences. You can find out all the data. We'll make it available in the description below the video. Thank you for watching, and hopefully we'll see you in the next video.